Hello dear students, welcome back to BYJU'S Exam Prep. Now under data structures and algorithms, we are talking about how to think recursively. So under this how to think recursively, we discussed many topics like recurrence relations and recursive functions. In this video, I discuss binary tree traversal technique. Okay. So there are three binary tree traversal technique like pre-order traversal, in-order traversal and post-order traversal. Okay. So let me start with that. Before that, if you want to know about me, myself Sridhar Dhulipala, I am having 20 plus years of teaching experience and I worked in all famous institutes in GATE, and from past 1 year I am associated with BYJU'S and I am working on a project called recorded GATE content. It is first of its kind and unique content. We created visualized animated content from past 1 year. And I recorded all these topics like discrete mathematics, algorithms, engineering mathematics, C programming and data structures. Except theory of computation, all my expertise were recorded. And you can find these subjects under BYJU'S Exam Prep app under the category Learn with Video Lessons. Okay. So please go through those videos. Those who purchase can access all the videos. Otherwise also you can access some of those videos. Am I clear? So let me start with today's topic, that is binary tree traversal. Of course, we simply call it as tree traversal, but okay, the idea is binary tree traversal we are going to discuss. See, tree traversal means we are visiting each node of the tree exactly once. Okay, we are visiting each node of the tree exactly once, and there are three conventional tree traversals. Okay, and first one is pre-order traversal, and second one is in-order traversal, and the third one is post-order traversal. Okay, so let me start with the first one, that is pre-order traversal. Even this traversal can be understood recursively. So first I'll tell you how you can traverse without using any shortcut technique. Then we try to see a shortcut technique for doing this traversal. So pre-order traversal means first we visit root, then we visit the nodes of left subtree in pre-order manner. That is recursively in pre-order manner. Then we visit the nodes of right subtree recursively in pre-order manner. So that is the idea of pre-order traversal. Pre-order means first root is visited, then the left subtree is recursively visited in pre-order manner, then the right subtree is recursively visited in pre-order manner. Am I clear? So for example, if I am having a small tree like A, B and C, what about the pre-order traversal of this? What is the pre-order traversal? Sorry, what is the pre-order traversal? See, what we do, first we visit root. So the pre-order for this is, first we visit root node, then we visit the nodes of left subtree in pre-order manner, and that too recursively. That is, we visit the nodes of left subtree recursively in pre-order manner. So here we have only one node, so B is visited. Then we visit the nodes of right subtree recursively in pre-order manner, because only one node is there, C is visited. So this is the pre-order traversal of this particular binary tree, my dear friends. Hope you understand. So this is about the pre-order traversal. Now what I do is I take up one example and let us see how we traverse this in pre-order manner. After this, I'll give you the shortcut for writing the pre-order traversal. Okay. So first let us see recursively how we can traverse the nodes of the tree. Nodes means these are called nodes of the tree, my dear friends. So we traverse these nodes of tree recursively in pre-order. Sorry. See, the story is simple, sir. When you want to do pre-order traversal, the first thing is we need to visit the root. Okay, let me use a different color. We need to visit the root node. So we visit the root node A. After that, the left subtree must be visited recursively in pre-order manner. The left subtree. What is the left subtree, sir? This entire story is your left subtree. This entire part is your left subtree. So the left subtree must be visited in pre-order manner. The left subtree must be visited in pre-order manner. So again, for left subtree, there is a root, there is a left subtree, there is a right subtree. Am I clear? So here also, first what is visited? The root node is visited. What is visited? The root node is visited. That is B is visited. Then what happens is, the left subtree is visited recursively in pre-order manner. The left subtree is visited recursively in pre-order manner. See, after B, first left subtree is visited recursively in pre-order. Again, for left subtree, if you observe, there is a root node. So root node means visit the root node. Then we have to visit the left subtree recursively in pre-order manner. Left subtree, only one node is there, so that is visited. After left subtree, because left subtree is completed, then you have to recursively traverse the right subtree in pre-order manner. So right subtree, only one node is there, that is recursively traversed. So this is how we completed up to this left subtree. Now root is completed here and the left subtree is completed. Now we move to the right subtree of this. The right subtree again need to be traversed recursively in pre-order manner. The right subtree must be traversed recursively in pre-order manner. So for that, first we have to visit root node. Then left subtree need to be traversed recursively in pre-order manner. Left subtree, only one node is there, that is traversed. Then right subtree. If you observe, there is no right subtree. Stop it. So this entire left subtree here is completed. First we visited root node. Then we completely visited the left subtree recursively in pre-order manner. Now we move on to the right subtree, my dear friends. Again, the right subtree need to be traversed recursively in pre-order manner. See that idea, if you keep it, you can directly write this pre-order traversal without using any technique. Anyhow, I am going to teach you a shortcut. Without thinking much, you can directly write the pre-order, but one should always understand this procedure which I am giving. Okay, see, if you properly follow the recursion, you can write this pre-order without using all the circles and other nonsense. Directly you can write pre-order traversal, my dear friends. Am I clear? So now the right subtree need to be traversed recursively in pre-order manner. First what we do? We traverse or we visit the root node. After visiting root node, we have to traverse the left subtree in recursively in pre-order manner, because there is only one node that is traversed, that is visited actually. Then what happens? The right sub, because left subtree is completed, then you move to the right subtree. Sorry. Okay, so right subtree, that is what? I. And this is how we visit all the nodes of the given binary tree in pre-order manner, my dear friends. If you have any doubts, please do ask me. Sorry. If you have any doubts, please do ask me. Now let us take this. Now let me give you the shortcut. But before giving you the shortcut, let us directly write down, without using any circles and other things, directly let us write down the pre-order traversal for this. If you understand what I discussed so far, you can easily write the pre-order traversal, my dear friend. Otherwise, we learn anyhow the shortcut. See, pre-order means what, sir? Pre-order means first root node, then the left subtree, then the right subtree. Here n means the root node, the node, then the left subtree recursively in the pre-order, then the right subtree recursively in the pre-order. Okay, so here what we do, first we write A, then left subtree we have to visit recursively in pre-order. Pre-order means what, sir? First we have to visit the root node, then the left subtree need to be visited recursively in pre-order manner. So left subtree means what is that? F, okay, root node, then the left subtree, then the right subtree. Now root is completed, left subtree is completed, then we move to the right subtree. Right subtree means what? G and M. Is the idea clear? Then we move to the, now root is completed, the left subtree is completed, then we move to the right subtree. Right subtree again need to be traversed recursively in pre-order manner. First root node, then the left subtree, then the right subtree. Because left subtree single node is there, directly visit that. So directly also we can write that. And one should develop this way of writing the traversals without using any of the shortcuts. Of course, we learn shortcut, there is nothing wrong, but one should always learn this. The recursion idea, that is how you traverse recursively in pre-order manner. That is very, very important, my dear friends. Okay. Now, let us see the shortcut. So, there is a shortcut which generally people follow. So, let me explain that particular shortcut for you, my dear friends. Okay. So, this generally Euler walk people call it, or some walk you can call it, no problem. So, what you do is this walk starts from here, from root node. And here, okay, let me use a different color so that you will not have confusion. And one more thing, if here before continuing with this, you see for every leaf node or a node with only single node, the null link, because it is a binary tree, means for every node maximum 2 links are possible. So, whenever the link is not available, you fill that link with a dummy node. So, this is dummy links we call it. What you call them? They are called dummy links. You create this dummy links, my dear friends, because for left subtree is the right subtree is missing, you create a dummy link. Here also left subtree, right subtree. So, whenever left and right subtrees are not there, you create 2 dummy links. If any one is there, for other one you create a dummy link. Okay, so that is the idea. For example, G only left subtree is there, right subtree is missing, so you create a dummy link. Of course, this is not a dummy link, this is the regular link. Okay, hope you understand. Clear to you all. Now, let us see the shortcut technique for writing pre-order. The same shortcut can be used for in-order and post-order also. For all the tree traversal, the same idea can be used. Okay, and in this, what is important is creating this walk. And first of all, before that, we need to remember that we need to create this dummy links. Create the dummy links, then continue the story. So here the story continues like this, my dear friends. It starts from here. Each node is visited 3 times. Each node is visited 3 times. First on the left, second on the middle, third on the right. Okay. So, let us see this walk. You will understand that idea, my dear friends. So, you visit the node, then you visit here, then you visit here, then you move. See, from left to middle and right, you are going to move. Now, for this, you visited this one time. Each of these nodes you visited one time. Now, for this J, you visited one time. Second time, we visit at the middle. And third time, we visit this node at right. And for every node, this will happen. We visit at left, middle and right. Continue this walk till A. Now, you continue. This is visited second time. Here, first time, this is second time. Now, you continue. K is visited first time, K is visited second time, and K is visited third time. Now, F is visited how many times, sir? Third time it is visited. Then for B, we visited B. Then G is visited first time. L is visited first time. L is visited second time. L is visited third time. G already visited first time. Now, we visit G second time. Sorry. Now, G is visited third time. B visited third time, because first time here, second time here, and third time we visited. Okay. Now, this is visited and this is visited. D is visited. Now, H is visited first time, second time in the middle, third time on the right. And D visited left, H, I visited left, middle and right. And D is visited third time. A is visited third time, like this. And you just need to traverse this from here. Like this, you need to traverse. And one important point we need to note here is, for every node, you visited 3 times. Okay. So, what you do is, you just give numbers 1, 2 and 3. And here also 1, 2 and 3. For every node, 3 times you visited, no, just write the numbers 1, 2, 3. For every node, you write down 1, 2, 3. 1, 2 and 3. 1, 2 and 3. 1, 2 and 3. This is also 1, this is 2, this is 3. This is also 1, this is 2, and this is 3. You got it? Now what you do is you traverse from here, you walk along this walk and print all once. Then you are going to get pre-order traversal, my dear. If you print all once along this walk, then you are going to get the pre-order traversal, my dear friends. Okay, so let me write down the pre-order traversal. See, I am starting my walk from here. I'll continue along this green walk, and whenever I find one of the node, I print that node. Only one I print. For pre-order, I have to print 1. For in order, I have to print 2. For post order, I have to print 3. That's it. That is the shortcut, nothing more than. Am I clear? You completed this shortcut within no time, my dear friends. But what is very important is, without using shortcut, directly writing pre-order is important. That you have to develop. Okay. Anyhow, shortcut is there. So let us start from here. First, you find one of A, you print it. Whenever you find one of a node, print it. Now you continue. Again, you find one, print the node. Again, you continue, find one of this node, print it. Again, you continue the walk. You find one of this node, print it. And here you travel. Now it is 2 and 3 you ignore, sir. For pre-order, you need to find only ones and you have to print them. You continue your walk. Okay. Continue, and again you find 1. 1 of K means print K. Then continue 2 and continue 3. Then 3. Then 2. Then 1. 1 of what? G, you print G. Then 1 of L, you print. Then 2 of L, 3 of L, you can ignore. See, I am just traversing along this, sir. I am just traversing along this green line from left to right. Okay. Now I find 2 and 3, I ignore. Again I find 3, I ignore. 2, I ignore. Again I find 1, I print it. Then I traverse. Again I find 1, H, I print it. Again I traverse. 2 and 3 I ignore. 2 is ignored. Then 1 I find it. So I print that. Is the idea clear? That's it. And all ones are completed. Continue your traversal. You don't find any more ones. And that is your pre-order traversal, my dear friend. And I written the same pre-order traversal already. A, B, F, J, K, G, L, D, H, I. So that is the pre-order traversal, my dear friend. Hope you understand. Any doubts? If you have any doubts in this shortcut, please ask me, sir. This is generally people call this as Euler walk. Don't go with your discrete mathematics Euler walk definition. Here we reach each and every edge. Because of that, they sometimes call this walk which I drawn in green as Euler walk, sir. That is a terminology which people use. You can just call it as a traversal walk. Okay, tree traversal walk. You can call. No problem. Any doubts? Please do ask me. If you ask any doubts, I'll continue, my dear friend. Otherwise, means if you have doubts, I'll clear them. Otherwise, I'll continue with my next one, that is Inorder traversal. Please ask me. If you have any doubts, please do ask me. Okay, fine. Now let us see the pre-order traversal pseudocode. I am not interested in discussing this pseudocode, my dear friends. So generally we call with the pointer to the root node. If root node is not null, that is the pointer to root node is not null, then you are going to do it. We visit the root node data, then we in recursively traverse in pre-order the left subtree. For left subtree, first you have to reach what, sir? The root node left child. Then we recursively traverse the right subtree in pre-order manner. So that is the simple pseudocode, my dear friends, for pre-order traversal. Okay, like that. Now comes the in-order traversal. Now let us see. No doubt, sir. Very good, A.B. de Villiers. Okay, I am seeing you after a long time. Good. Now let us move on to the in-order traversal, my dear friends. In-order traversal. See, for in-order traversal, how you traverse, sir? First, we traverse the left subtree recursively in order. Traverse left subtree recursively in order. That is the idea we need to understand. Then we visit the root node. Then we traverse the right subtree recursively in order. That is the story, my dear friends. Okay, so let us see this. So this is the story. So if I take a simple binary tree A, B, C. So first here in the Inorder traversal, first we Inorder means where is the root. Based on where is the root printed, we got this pre-order, in-order and post-order. In pre-order, root node is printed first. That's why we call it as pre-order. In the in-order, root node is printed in between. That's why it is called in-order. And in post-order, root node will be printed after recursively traversing left and right subtree. Here, root node is printed in between the left and right subtree. That is, first left subtree is traversed recursively in order, then the root node is printed, then the right subtree is traversed recursively in order. Now here, what about in order for this? What about in order for this? First, left subtree is traversed. Here left subtree single node is there, that is printed. Then the root node A is printed. Then the right subtree, that is C, is printed. So this is your in order traversal, my dear friend. Hope you understand. Clear to you all? Now let us take example and let us write down in order traversal. Story is same. For in order, please remember what we need to do. First, left subtree need to be traversed in order. So first we have to traverse the left subtree. After that, A is printed. Then the right subtree is traversed in order. Okay. So first left subtree. Again, left subtree need to be traversed recursively in order. In order means for that, whatever left subtree is there, that has to be traversed first. Then root, then right subtree. So here this left subtree need to be traversed first. And here again this has to be traversed in order. In order means first left subtree, then the root, then right subtree. So for this, because it is a simple one, directly you can write J, F. Now left subtree is completed, then the root node is visited. B is visited. Then what happens? The right subtree is visited in order. Right subtree is visited in order. Again in order means for this first left subtree, that is L, is visited. Then the root node, which is G, is visited. Then the right subtree, but right subtree is missing, stop it. So this entire left subtree you completed, my dear friend. BAC, wonderful, wonderful, AB de Villiers, very good. Good. Sorry, I haven't seen that. Good. Yeah, you're perfect, perfect. G, F, K, B, L, G, A, H, D, H, very good. Okay. Now here you travel, because left subtree is completed, then you visit the root A. Then you have to visit the right subtree in order. Again, in order for this means what? H, D. Hopefully, de Villiers is writing this in order without using any shortcut technique. That is wonderful method. Directly by looking at tree, if you can write the in order without using any of these circles, then you perfectly understand the recursion, my dear. The recursion idea you are having perfectly in your mind. Please remember that. That is wonderful. Better technique. Okay. So again, let us see this example before going for shortcut. Very good, AB de Villiers. That's wonderful. In order, if you want to write, first you have to recursively traverse the left subtree in order, then root, then right subtree recursively in order. So here what we do, first we write B. Is it B? First we have to go for the left subtree. Left subtree means in that left subtree recursively in order. So again F, this left subtree is FJK. Again that need to be traversed recursively in order, means first J comes, then F comes, then K comes. Okay, J, F, K. Then again left subtree is completed, root node is printed. Then the right subtree is traversed in order. In order means first left subtree, that is L, then the root node. Now complete left subtree is completed. Now root node A is visited. Now right subtree in order you have to traverse. In order means H, D, I. Like that. Perfect. If you understand, fine. Otherwise, you can slowly, initially, you always give that circles and draw left, right, like that. You can do it, my dear friends. Okay. Sorry. Yeah. Now let us see the shortcut, which most of the people are interested. And before shortcut, please remember this dummy links need to be given. Whenever any left or right subtree is missing, but that is for leaf node, we need to give two dummy links. Okay. For example, you see G for G left subtree is there, but right subtree is missing, only one dummy link need to be given. So that you please remember, sir. The dummy link need to be drawn for this shortcut method. Okay. So let us draw the walk. Traversal walk you can call, some people also call it as Euler walk. So we start from here. Each node to be visited 3 times. One on the left side, one at the middle, one on the right side. Okay. Even this method is very interesting, sir. Same story which we done earlier. Each node to be visited 3 times. Left, middle and right. Left. Okay, already left is completed, middle and right. Now this is right because left is completed, middle is completed, right. Then middle. Then again left, left, middle and right. Middle, left and middle, right, right. So that is your walk, traversal walk we call it. Okay. Some people call it as Euler walk also, there is nothing wrong. And please give the numbers like 1, 2, 3 for each node. 1, 2, 3. And you have to traverse from left to right. Okay. And whenever you find 2, you have to print the node. That is for Inorder, sir. For pre-order, you printed once. Okay. Left dot is for pre-order. Very good. You can write left dot. Some people use the numbers, sir. I am a mathematical person, so I use numbers also. I like numbers. Okay. Some people just use the left, middle, right dots, they'll call it. You can keep this 1 to 3 numbers. Your wish. Okay. There are different ways. Yeah. Wonderful, ABD Villiers. Thank you for helping me. Okay. So you start this traversal. And whenever you find 2 for a node, print that node. And that is your Inorder traversal, my dear friends. So you start walking, and whenever you find 2, you print the node, my dear friends. For Inorder, 2 to be printed, or middle dot, as our friend AB de Villiers is saying. Some people use the left, middle and right dots. Left dot is for pre-order, or 1 for pre-order, middle dot or 2 for Inorder, right dot or 3 for post-order. That's it. Okay, so let us see this. You traverse, once you can ignore. Now you find first 2, print that. Then second 2 at F, print it. And third 2 at K, print it. Continue your walk. And again you find 2 at B, print it. Again you continue the story. Again at L you find 2, that is middle dot, as our friend says. And this one, right, continue. Again you find 2, G, you print it. Be careful, sir. When you are walking, only the 2's need to be printed. And don't miss anything. Okay. If you miss, the story will be messed up. Right. Continue. Once you can ignore, then 2H. Then continue the story. Then you traverse. Then again 2 for D. 1, 2 for I. That's it. All 2's are completed. Go back. And that is your traversal walk. And you have to print all middle dots or number 2's, my dear friends. Perfect. That is the story. That is Inorder traversal. And as I told you, without using this technique, if you can write down this Inorder traversal, then it means you understand the recursion perfectly. That we need to develop. Without using this technique, we need to develop directly writing the Inorder or pre-order or post-order, my dear friends. For that, we just need to remember this. For pre-order, first root is visited, then the left subtree visited recursively in pre-order, then the right subtree visited. That is, the nodes of right subtree are visited recursively in pre-order. When it is in order, first what happens? The nodes of left subtree are visited recursively in order, then the root node is visited, then the nodes of right subtree are visited recursively in order. Same is the case for post order. For post order, what happens? Root will be visited last. That is, the nodes of left subtree are visited recursively in post order. Then the nodes of right subtree are visited recursively in post order. Then the root node is visited. So that is the story, my dear friend. Am I clear? And of course, this is the pseudocode. जनरल ट्री के लिए ट्रैवर्सल लिख सकते हैं सर? जनरल ट्री के लिए we cannot have the same story like pre-order, in-order, my dear friends, because there are the pre-order, in-order and post-order obviously for when you have left, right and middle. But when you have general subtree, we can have some other traversal. Generally, people use that level order traversal for general trees, my dear friends. Okay. Okay. Mainly, we are studying this for binary tree traversal. See, mostly by default, tree traversal means we talk about binary tree traversal only. For general trees, mostly we go for this level order traversal. Even for binary tree, we can have the level order traversal, my dear friends. Okay, no problem. Now comes the post order traversal. The story is the same. First, what we need to do, we need to visit the nodes of left subtree recursively in post order. Then we have to visit the nodes of right subtree recursively in post order. Then we have to visit the root node, my dear friends. So that is the story. Am I clear? Okay. So when you write a simple binary tree, what about post order for this? What about post order for this? First left subtree visited, then right subtree visited recursively in post order, then root node. So first left subtree, then right subtree, then the root node is visited. That is the story. Can you give the post order for this? What is post order for this? We always experiment with the problem. Suppose some nodes are there, remove and see what happens to the post order. Don't fix yourself to the problem which is given. Try to explore, remove some nodes and see what about the post order. Okay, whether you could able to write it or not, you check it. That is very important. Okay, experimentation is very, very important after you understand a concept. Generally, what people do, I see that they take a simple formula or a simple concept, they apply only to the problem given to you. Once you understand, it can be applied to any binary tree. You can draw your own binary tree and you can do that traversal for that. Please develop that methodology, my dear friend. Experiment. Okay. But after understanding the concept. Without understanding concept, don't ever experiment. Okay. Please remember. What about post order for this? Anyone giving post order for this, sir? Okay. So here left subtree, right subtree missing. So let it be. Then BA is the post order traversal. Am I clear? So that is the post order traversal. So let us write down the post order for this using the circles post order. See, for post order, what we do, sir? First, we have to traverse the left subtree in post order. That is, we have to traverse the nodes of left subtree recursively in post order, then the right subtree, then the root. Correct? So first left subtree need to be visited recursively in post order. Again for that there is a left subtree, there is a right subtree. So that need to be done. Again for this there is a left subtree. So this need to be visited recursively in post order. Am I clear? So directly you can write now. When you have just three nodes A, B, C, you can write that. So for this it is G, K, F. Now the left subtree is completed. Then what we need to do, we have to visit the nodes of right subtree recursively in post order. Again for this, what is it? Left, sorry. Left, right is missing. So let it be. Then G. Now left subtree completed, right subtree completed. Then finally, we have to visit the root node. We have to visit the root node. And what is the root node, sir? Is the idea clear? Now we completed the left subtree. Now we have to visit the right subtree. Again, right subtree need to be visited recursively. That is, right subtree visited means right nodes of the right subtree need to be visited recursively in post order. Visit the nodes of right subtree recursively in post order. For that again directly DHI now, directly you can write what is it? HID, because it is post order. Now left subtree completed, right subtree completed. Finally the root node, which is Is the idea clear? Hope you all understand. Good. If you have any doubts, please do ask me, sir. Now let us see our shortcut. For shortcut, what we need to do, sir, just create dummy links whenever it is needed. Start from here. Left dot, as our friend said, or 1, 2, 3, anyone. Left, left, middle, and right. Middle, left, middle, and right. Right, middle, left, left, middle, right, middle, right, right, middle, left, left, middle, and right, middle, left, middle, and right, 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 and go. And if you want, you can write numbers, or if you understand the dot philosophy, follow that. Nothing wrong. 1, 2, 3s or dot philosophy. See why we write 1, 2, 3s? Because dots you may forget, but 1, 2, 3s generally, you know, there are 3 different ones, no? Because left dot, middle dot, and right dot, all of them may look same. That's why this 1, 2, 3 numbers are used. There is nothing more than that, my dear friends. If you use dot philosophy also, there is nothing wrong. Any methodology you can follow. Yes, wonderful, Mr. De Villiers. Okay. Bahut badhiya. Okay. So now you traverse from here. Now you have to print whenever you find 3, my dear friends. Whenever you find 3, you have to print. So traverse from here, then here, then here, then here, then you go here, then you find 3. So 3s you have to print, my dear friends. All the 3s you have to print. J printed, then go here, then go here, then 2, then 3 you find printed, then 3 you print F. Then 2 here, 1, 1, 1, 2s are ignored, 3 is printed, that is L. 2 ignored, 3 means that G node is printed, again 3 means B is printed. Now left subtree is completed, again 2 ignore, 1, 1 and 2 ignored, 3 H is printed, then 2, 1, 2, 3 printed, 3 means I is printed, correct? Then D is printed, then finally A is printed, and that is your post order traversal, my dear friends. It's a very, very simple technique, my dear friends, but I generally ask people to write this post order without using these techniques. Techniques are always good, but without using technique, one should write this traversals, my dear friends. Okay, that is, first you have to complete the left subtree, then right subtree, then we have to print the root node. So left subtree again in post order manner. So left, again left. In that, what happens? J, K, F. Then right subtree recursively in post order manner, that is L. Right subtree missing, so G, then B. Now again right subtree in post order means H, I, T, and finally A. So that is the idea one need to develop, my dear friends. Okay, so directly if you can write, the answer will be the same, it will not be different, but one should always develop that idea. Of course, anyhow, we have this 1, 2, 3 technique that anyhow help you. Initially, you start with this 1, 2, 3 technique and please develop that. Means one should know how to read that pre-order, post-order and in-order. Pre-order means what, sir? Okay, let me give. First of all, please tell me what is pre-order. We should remember always this one. Pre-order means root. I am writing N for root. Root, left subtree and right subtree. That is, first root node is visited, then the left subtree is recursively visited in pre-order, then the right subtree is recursively visited in the pre-order. Now what about in order, my dear friends? First left subtree, the nodes of left subtree are visited recursively in order, then the root node is visited, then the nodes of right subtree are recursively visited in order. Then comes the post order, my dear. Post order means first left subtree, that is the nodes of left subtree are recursively visited in post order. Then the nodes of right subtree are recursively visited in post order. Then the root node is visited. N means root node, my dear friend, or the node. So that is the idea, my dear friends. Okay. So let us write down the pre, in order and post order for this. You can use that traversal walk to get the answers, or directly you can write the answers. Someone is giving pre-order, very good. Wonderful, wonderful AB de Villiers. Okay. So for those who want this, I'll give you the walk. Otherwise, we'll create directly. Of course, here I not use the link, but if you remember left, middle and right, it can be done. Suppose if you have confusions, always write down the links, sir. Dummy links you create and continue. Am I clear? Dummy links you create and continue. Okay. If you can draw this walk without the dummy links, that is left, middle and right, you can continue like that. Generally, I suggest 1 to 3 as I told you why. Because the middle and right people may confuse, but 1, 2, 3 when you have at once you are printing pre-order, at 2s you are printing in order, and at 3s you are printing post order, then that would be easy for you. Okay? Because middle and left and right dots may look same, so people may get confusion. Okay, you can write 1, 2, 3s, or as our friend suggested, middle, left, I mean left and middle, left, middle and right dot also you can see. Okay, you can print all 1s, 2s and 3s, my dear friends, to get the pre-order, in order and post order. Pre-order means 1s, that is A, then B, then D, then E, then F, then G, then C, then H is missing now, and then I. That is pre-order. In order means 2s. Starting from here, 2s you have to print D, B, then F, after F, G, then E, then A, then C, then I, then H. That is it. Wonderful, AB de Villiers, you are doing very fast. Post order. What about post order? All the 3s you have to print D, then G, then F, then E, then B, then continues this way, and then I, and continuing this way, then H, then C, and A. You just need to traverse along this and print all the 3s. Okay, D, G, F, E, B, I, H, C, A. Perfect. AB de Villiers. Wonderful. That is the idea. But as I told you, without using this, one need to draw that. That we need to develop. For that, what we need to remember? Pre-order means first root node, then the left subtree recursively in pre-order, then the right subtree recursively in pre-order. In order means what, sir? First left subtree, then the root node, then the right subtree. Post order means what? First left subtree, then right subtree, then the root node. Whenever you say left and right subtree, the nodes are visited recursively in that particular order. That one need to remember, sir. Am I clear? So that is the idea. Hope this is same problem. Okay, I think the same problem, sir. So let us write down the pre-order without using the links. So pre-order means what? First root node is printed, then the left subtree is printed or visited in pre-order. Pre-order means again here B, then the left subtree visited, only D is there, then the right subtree. Right subtree again visited first root node, then the left subtree. Left subtree means first root node is visited, right left subtree missing, then the right subtree. Then here root completed, left subtree completed, then right subtree need to be visited recursively in pre-order. So first root node, left subtree not there, then right subtree. Right subtree again in pre-order means, see when you go there, just remember that pre-order. Pre-order means first you have to print it, then you have to print the left subtree, which is I. Directly you can write it. Am I clear? Then what about in order? In order means first you have to complete the left subtree, then we have to visit root node, then we have to complete the right subtree in order. So first you have to go for left subtree. Again when you go here, first again left subtree, you go here. First left subtree is not there. Then you have to print D, then right subtree missing. Done. So left subtree is completed. Okay, in order. So left subtree completed means now B to be printed. Then right subtree in order. In order means first left subtree to be completed. Again here left subtree means left subtree is missing. Done. Then root node. Then right subtree. Right subtree again in order. In order means first left subtree not there, so root node. So left subtree completed, then the root node, that is E. Okay. See, we completed this entire left subtree, my dear friend. Again what? Root node. Because left subtree completed, then the root node. Because it is in order traversal. Am I clear? Then the right subtree in order. So when you go here, first in order means first go to complete left subtree. Left subtree is missing, then you print root node. Then right subtree in order. So when you go here, first you have to print left subtree. Left subtree again root node, only one root node is there, left and right missing. So only first left subtree not there, so root node is printed, right subtree is missing. Now left subtree is completed means H is printed. Then right subtree, that is missing. Done. So that is the story, my dear friends. So that is your in order. Okay. So similarly the post order. So for post order also the story is same. Remove all this that you will not get any confusion. See, just remember every time the same idea. Post order means what? First left, then right, then root node. So first when you go here, first complete left, then right, then come here. So first you go left. Again here same story. First complete left, go left. First complete left, there is no left. Then complete right, there is no right. Now you print the root node. D is printed. Now because left is completed, you go back to the right subtree. Because for this node left is completed, go to the right subtree. Again right in the post order manner. Means first you go to the left subtree, complete, then you have to go for right subtree. Again here complete the left subtree. It is not there. No problem. Then complete right subtree. Right subtree single node is there, print that. Now right subtree completed, then you print the root node. Now the left subtree completed, then you move to the right subtree which is empty. Therefore you print E now. Now the left subtree, right subtree completed, now you print the root node which is B. Now left subtree is completed, now you have to go for the right subtree in post order. Post order means first left subtree not there. Then right subtree in post order. Post order means first left, then right which is not there, then root node. Now left, right completed, then the root node. Now this complete left is completed, right is completed, now the root node print. And that is it. Hope you understand. And this is about your binary tree traversals, my dear friends. If you have any doubts, please do ask me about this tree traversal. And tomorrow we talk about the most important topic, that is matrix chain multiplication. Okay. If you have any doubts, you can ask me, sir. Any doubts? And please remember, this direct writing of this traversals is very important. 1, 2, 3 technique is good. Okay. But later on when they give you pre-order and in-order, then you have to write post-order. In such cases, direct writing of the traversals becomes very, very important. Okay. Initially, you can always use this 1, 2, 3 technique, my dear friends. Okay. That 1, 2, 3 technique is generally for college level examinations. But for this level, we should directly learn how to write this pre-order, post-order and in-order without using any 1, 2, 3. Wonderful, DV. Thank you. Thank you. Okay. Tomorrow, same 8 p.m. matrix chain multiplication. We'll discuss this tomorrow 8 p.m. That's all for today. Thank you, sir. If you have any doubts, you can write, sir. I'm waiting for your doubt. From pre-order and in-order, we'll construct binary tree. Yeah, binary tree, if you construct, then you can write any order, no? From pre-order, in-order, you can construct binary tree. From post-order, in-order, you can construct binary tree. And if it is a binary search tree, from pre-order, post-order also, you can construct binary search tree. If it is binary search tree. Normally, from pre-order, post-order, you cannot construct binary tree, sir. But if it is a binary search tree, from pre-order, post-order also, you can construct binary search. If it is binary search tree. Actually, level order traversal with pre-order can also construct the binary tree, my dear friend. Level order with in-order traversal. Okay. Am I clear? Any to calculate post-order traversal? Yeah. All these are different techniques. See, I'm just using the idea of recursion. See, my main purpose of this video is not to discuss all those problems, sir. That is entire story. Binary tree traversal is a very, very important topic for GATE point of view. My main idea is to introduce the recursion. Wherever you find recursion, see, the topic name is how to think recursively. I started with recurrence relations, then I started with recursive functions. Now I am doing this binary tree traversals, which involves recursion. See, if you understand recursively, then this traversal can be written directly. If you don't understand the recursion, then you have to use 1, 2, 3s. If you are using 1, 2, 3s, initially fine. Okay, I am not saying that is wrong. But if you want to understand, if you want to think recursively without using 1, 2, 3, we should write this. That is the main idea. One who develop this methodology, directly writing without using 1, 2, 3s, this pre-order, post-order and in-order, they understood recursion properly, because that is the meaning of thinking recursively. Using 1, 2, 3, if you write it, wonderful. You know how to solve problem. And mostly in GATE examination, if you know how to solve problem, most of the problems can be solved. But if you want to learn this recursive problem solving, you need to develop this directly. That is what I'm trying to say. So because the topic name is how to think recursive. Pre-order means what? Pre-order means first root node is visited, then the left subtree, the nodes of left subtree are visited recursively in pre-order, then the nodes of right subtree are visited recursively in pre-order. That idea one should develop. That is what you mean by thinking recursive. See, problem solving is different. Thinking recursively, that is, solving recursive problems is different, but thinking recursively and solving those problems is different. So that is the main aim of this topic, my dear friends. I just want you to understand how to think recursive. Okay, and as one of my friend who is answering, only he is answering, I don't know about others. See, I generally expect student to discuss. I never stop student asking doubts in my class. Anytime you can ask doubts. Okay, thank you very much, sir. Good night, take care. Thank you very much, Mr. A.B. de Villiers. If you have any doubts, please ask me. Tomorrow's class 8 p.m. the most important matrix chain multiplication. I'll give you a simple method for solving this matrix chain multiplication. Thank you.